in the silence beneath the ancient sky, long before the first hominid lifted its gaze to the stars, the world was ruled by colossi. The Mesozoic Earth was a tapestry of vast forests and steaming swamps, continents unrecognizable in their drifting youth. Oceans teemed with leviathans, and the land trembled beneath the tread of the dinosaurs, creatures whose names would echo through the corridors of time. Tyrannosaurus, Triceratops, Ankylosaurus, Apatosaurus, and the swift, cunning Velociraptor. For nearly 165 million years, these beings flourished, adapting and thriving through the slow, relentless churn of evolutionary change. Yet, in the fossilized bones and petrified memories of these vanished giants, a question lingers. A question as old as the first fossil unearthed in the chalky English cliffs at Lyme Regis. What truly killed the dinosaurs? To unravel this enigma is to peel back the layers of deep time itself. It demands more than a glance at museum skeletons or a child's mural of roaring beasts. It requires a journey into the heart of planetary catastrophe and cosmic chance, into the interplay of geology, climate, biology, and the relentless accident of fate. For the end of the dinosaurs was not a single moment, but a cascade of events, a convergence of terror and silence, of fire and darkness, of life's immense vulnerability. Let us draw back the curtain of eons and reconstruct, with the precision of a paleontologist's brush and the imagination of a poet, the last act of the Mesozoic world, a drama written in stone and shadow, in the language of shattered strata and chemical residue. The story begins not with an ending but with a world at its zenith. The late Cretaceous, some 66 million years ago, was an age of abundance. Across the supercontinent Laurasia, lush forests of flowering plants, magnolias, sycamores, fig trees, spread beneath the sun. On the southern landmasses of Gondwana, strange titans like Argentinosaurus browsed among cycads and ferns. The temperatures were balmy, seas flooded the continents, and the poles were capped not in ice but in forests. Life radiated in dizzying variety. Flying pterosaurs wheeled above. Marine reptiles like mosasaurs hunted in the warm, shallow seas, and mammals, still small and furtive, scurried beneath the feet of giants. Yet this vibrant world was not without its shadows. The fossil record, so often a catalogue of abrupt change, hints at unease. In the last few million years of the Cretaceous, some lines of dinosaurs dwindled in diversity. The great sauropods, those long-necked wonders, had vanished from North America, their place taken by herds of horned and armored herbivores. Flowering plants were transforming the landscape, outcompeting the ancient conifers and cycads upon which some dinosaurs depended. Insects were evolving alongside these plants, reshaping the food web. And deep beneath the crust, the earth itself was stirring. Volcanic rumbles in what would become India released torrents of gas and ash, foreshadowing convulsions to come. But in the grand sweep of time, these changes were gradual, the slow turning of ecological gears. The world was, in every measurable sense, alive and well, until in the space of a geological heartbeat everything changed. It is here that the story diverges into mystery and debate, a tangle of clues, hypotheses, and passionate scientific rivalry. For decades, the extinction of the non-avian dinosaurs was wrapped in enigma. Early paleontologists speculated on disease, competition, climate change, even cosmic rays. But in 1980, a discovery by the Alvarez family, Luis Alvarez, a Nobel-winning physicist, and his son Walter, a geologist, turned the world of paleontology on its head. They were studying a thin, dark band of clay in Italy's mountains, a layer marking the boundary between the Cretaceous and Paleogene periods, what would come to be known as the KPG boundary. In this layer, they found an anomaly, a concentration of the rare element iridium, dozens of times higher than in surrounding rocks. Iridium, scarce on Earth's surface but abundant in asteroids and comets, seemed a silent signature of catastrophe. The Alvarezes proposed a radical idea. A massive extraterrestrial object had struck Earth, unleashing devastation on a planetary scale. Their hypothesis electrified and divided the scientific world. Skeptics countered with alternative explanations: volcanic eruptions, gradual climate shifts, sea level changes, or ecological collapse. Some argued for a more complex scenario, that the end of the dinosaurs was not a single blow, but a death by 1,000 cuts. The debate raged across continents and decades, each new fossil and core sample a clue in a planetary whodunit. Yet, as the dust of argument settled, evidence for a cosmic impact mounted to overwhelming heights. The smoking gun emerged in 1991, beneath the Yucatan Peninsula of Mexico. There, hidden beneath younger sediments and the green canopies of the jungle, lay the buried remains of a colossal crater, Chicxulub. Measuring more than 180 kilometers across and over 20 kilometers deep, it marked the scar of an impactor estimated at 10 to 15 kilometers in diameter, an object traveling at 20 kilometers per second, striking with the force of 100 million megatons of TNT. The forensic evidence was compelling: shocked quartz, tiny spherules of molten glass, and tsunami deposits spread across the Gulf of Mexico and Caribbean. Core samples extracted from the crater's peak ring, analyzed by teams led by scientists such as Joanna Morgan and Sean Gulick, revealed a sequence of devastation and recovery. A layer of melted rock, overlain by a rain of glass beads, and then by a darkness, rich in soot and carbon, the residue of world-spanning wildfires. But to understand what really killed the dinosaurs, we must look beyond the impact itself, to the chain of consequences that followed. For the collision was not merely a spectacular explosion, but the trigger of a planetary chain reaction, its effects rippling through every ecosystem on Earth. Imagine that moment. In the seconds before impact, the world is as it has always been. Then, a sun brighter than 1,000 dawns flashes over the Yucatan horizon. The asteroid vaporizes upon contact, carving a hole wider than any mountain, hurling trillions of tons of rock and sulfur high above the atmosphere. The atmosphere ignites. Shockwaves race outward at hypersonic speed, flattening forests thousands of kilometers away. Tsunamis, hundreds of meters high, surge across the Proto-Caribbean, smashing into the coasts of North America and what would become Africa. In the hours that follow, molten rock and droplets of glass rain down upon the continents, igniting wildfires that race across the planet. The soot and ash, mingled with dust and vaporized sulfur, rise into the stratosphere, forming a veil that shrouds the world in darkness. Sunlight, the engine of photosynthesis, is blotted out for months, perhaps years. Earth's temperature plummets. A nuclear winter descends, halting plant growth, starving herbivores, and in turn, the carnivores that depend on them. Acid rain formed from the sulfuric aerosols falls upon the land and sea, acidifying lakes and oceans, killing plankton and corals. The food web collapses, first on land, then in the seas. The climate whiplashes. After the initial freeze, greenhouse gases released by burning forests and vaporized limestone send temperatures soaring in a hothouse aftermath. This is extinction not as a singular moment, but as a rolling tide of death. Weeks, months, years in which 75% of all species vanish, including every non-avian dinosaur, the great flying pterosaurs, the marine reptiles, the ammonites, and countless plants and plankton. Only those creatures small enough to hide, to burrow, to wait out the darkness, to feed on detritus or carrion or seeds, only they survive. Mammals, birds, crocodilians, turtles, and a scattering of other hardy lineages slip through the needle's eye. The fossil record, read in this light, is a chronicle of apocalypse. At Hell Creek in North America, the transition from dinosaur-rich mudstones to barren layers above the boundary is abrupt and total. In Denmark, New Zealand, and Antarctica, the same iridium anomaly is found, the same layer of soot and glass spherules, the same extinction pulse, sediment cores from deep seabeds, analyzed for microfossils by scientists like John Smith and Gerda Keller, show a sudden crash in plankton populations, a blanketing of the ocean floor in clay. Yet, as the dust settles, the question remains: Was this impact, as cataclysmic as it was, the sole executioner? Or did it merely strike the final blow to a world already weakened by slower poisons? Here, the story deepens, drawing us into the uncertain terrain of Earth's own fury. For in the last million years of the Cretaceous, the Indian subcontinent was in the grip of volcanic convulsions, unlike any seen before or since. The Deccan Traps, a vast province of basaltic lava, erupted in pulses, covering more than 1 million square kilometers, releasing gigatons of sulfur dioxide and carbon dioxide into the air. These eruptions, dated by radiometric methods to within 100,000 years of the impact, would have driven acid rain, climate cooling, and atmospheric chaos. Some scientists, led by Gerta Keller and Vincent Cortillo, argue that the Deccan volcanism was a primary driver of extinction, weakening ecosystems, altering climate, and pushing species to the brink even before the asteroid fell. Others contend that the impact was the coup de grace, the event that transformed a world in slow decline into a graveyard. The latest data, drawn from high-precision dating of lava flows and impact ejecta, suggest a deadly synergy. The two disasters overlapped, their effects compounding in a planetary perfect storm. To see these debates is to witness science in its most vital form, a living dialogue shaped by new evidence and shifting ideas. The extinction of the dinosaurs is not merely a solved mystery, but an ongoing investigation, a tapestry woven of competing voices and evolving data. It is a story not just of death, but of survival, of the resilience of life in the face of unimaginable catastrophe. Let us linger then in the aftermath, the world remade by fire and shadow. The first years after the impact were a crucible. Forests burned and regrew, then burned again. The skies cleared, the sun returned, and the survivors crept from their refuges. Small mammals, once the underdogs of the dinosaur age, found a world emptied of giants. They diversified with astonishing speed, radiating into new niches, giving rise to the primates, the bats, the whales, and in time, to us. Birds, the only dinosaurs to survive, adapted to a changed world, their beaks and wings evolving in step with new plants and insects. Crocodilians and turtles, denizens of rivers and lakes, endured with little change, their ancient forms testaments to evolutionary conservatism. The Earth, in the slow, patient way of deep time, healed itself. Yet the echoes of that day in the Yucatan linger still. The crater is hidden, but its consequences are everywhere. In the mammals that rule the land, in the birds that fill the sky, in the absence of thunder lizards from our forests and plains. The age of dinosaurs ended not with a whimper, but with an explosion, one that opened the door for the age of mammals, and ultimately for the rise of human consciousness. The story of the dinosaurs' extinction is thus not a closed book, but a cautionary tale written in stone. It is a reminder of the fragility of life, of the power of contingency, of the ways in which the universe can, in a single moment, rewrite the fate of a planet. For if the asteroid had missed or struck a different place, or if the Deccan Traps had erupted more gently, the world might still be the kingdom of dinosaurs, and mammals, if they existed at all, might still be cowering in the shadows. This realization is both humbling and awe-inspiring. It invites us to see ourselves not as masters of the earth, but as heirs to a legacy shaped by chance and catastrophe. The same forces that ended the reign of the dinosaurs, impact, eruption, climate change, still threaten us today, their potential undiminished by the passage of eons. The iridium layer beneath our feet is a warning. Life is resilient, but not invincible. The search for what really killed the dinosaurs, then, is more than a matter of paleontological curiosity. It is a mirror held up to our own time, a lesson in humility, in the interconnectedness of all things, in the necessity of understanding the planet we call home. It is a story that binds us to the deep past and to the uncertain future that lies ahead. As we close this chapter, let us remember the dinosaurs, not as monsters but as the rulers of a vanished world, brought low by forces beyond their comprehension. Let us honor their memory with wonder, with gratitude, and with vigilance, for in their extinction lies the seed of our own existence and the shadow of our own mortality. The last echoes of the Cretaceous fade, and a new symphony begins, the symphony of the Cenozoic, of mammals and birds, of forests and grasslands, of the slow, inexorable rise of intelligence. The dinosaurs are gone, but their story remains, written in bone and stone, in molecules of iridium and layers of ash, waiting for those with eyes to see and minds to wonder. In the end, it was not simply an asteroid, nor a volcano, nor a changing climate that killed the dinosaurs. It was the interplay of all these things, a world in flux, a planet beset by catastrophe and chance, a fragile web of life tested to its breaking point. Their extinction was both an ending and a beginning, a reminder that in the vast theater of time, even the mightiest are at the mercy of the cosmos. And so the question, what really killed the dinosaurs, is answered not with a single word, but with a story of fire and ice, of darkness and rebirth, of the endless dance between life and death. It is a story that continues, as long as there are those who listen to the stones and dream of worlds lost and worlds yet to come.